Imagine waking up to news that the sun is going to explode tomorrow. What would happen to Earth? This mind-bending hypothetical plunges us into the depths of cosmic possibilities. The sun, our closest star, is the linchpin of our solar system, bathing us in light and holding the planets in orbit with its gravitational might. It fuels life on Earth with its ceaseless energy. The thought of it vanishing in a cosmic flare is nothing short of apocalyptic. While it's an unsettling thought, let's explore what this cosmic event would actually mean for us. To understand the fate of the sun, we first need to dive into the life cycle of stars. The journey of a star begins in a nebula, a vast cloud of gas and dust. It's in these cosmic nurseries where gravity pulls material together, forming clumps that grow warmer and denser over time. When the core of a new star gets hot and dense enough, nuclear fusion ignites. This is the birth of a star, known as the protostar phase. As the star matures, it enters what's called the main sequence phase. This is the longest period in the life of a star, where it is relatively stable. During this stage, the star fuses hydrogen, its primary fuel, into helium. This process releases a tremendous amount of energy, which is what makes stars shine. Our sun, a typical main sequence star, has been burning bright for about 4.5 billion years, and it's expected to continue for about 5 billion more. But what happens next? As a star exhausts its hydrogen supply, it moves into the later stages of its life. For a star like the sun, the next phase is the red giant phase. In this stage, the core contracts while the outer layers expand and cool, causing the star to swell dramatically. The color changes to red due to the cooling surface. However, not all stars go out quietly. Some end their lives in a spectacular explosion known as a supernova. This dramatic demise occurs in stars much more massive than the sun. In a supernova, the core of the star collapses under its own gravity, and the outer layers are blasted away into space, enriching the cosmic neighborhood with heavier elements which can become part of new stars, planets, and even life forms. The conditions necessary for a supernova include having a mass at least 8 times that of the sun. Since our sun doesn't meet this criterion, it won't end as a supernova, but will eventually shed its outer layers, creating a beautiful planetary nebula and leave behind a white dwarf. Now that we understand how stars evolve and die, we can better assess the sun's current stage and its eventual end. Given what we know about the life cycle of stars, could our sun actually explode? Let's delve into the cosmic conditions necessary for such a cataclysmic event. In the universe, stars that end their lives in a brilliant explosion, known as a supernova, typically possess at least 8 times the mass of our sun. This immense mass is crucial because it determines whether a star will explode as a supernova or not. The process begins when these massive stars exhaust their nuclear fuel, leading to a catastrophic collapse under their own gravity, followed by a spectacular explosion. Now, turning our gaze to our own celestial guardian, the sun, it's important to understand that it is classified as a medium-sized star, specifically a G-type main sequence star. With a mass far below the threshold necessary for a supernova, the sun's fate involves a much quieter and gradual transformation. As it ages, the sun will exhaust the hydrogen at its core and begin to fuse helium into heavier elements. This process will cause the sun to expand enormously into what is known as a red giant. This phase of the sun's life will see it engulfing the inner planets, including potentially the Earth. Eventually, the outer layers of the sun will drift away into space, leaving behind a hot core known as a white dwarf. This white dwarf will then gradually cool and fade over countless millennia. So, while the sun won't explode, its transformation will still be a spectacular sight, billions of years from now. Now, let's entertain the hypothetical scenario where the sun explodes tomorrow. Imagine waking up to a day like any other, but suddenly, the sky goes dark, permanently. The sun, the heart of our solar system, has exploded. This cataclysmic event would initially go unnoticed on Earth for about 8 minutes, the time it takes for light to travel from the sun to our planet. After these 8 minutes, the world would plunge into darkness. Firstly, without the sun's light, photosynthesis would halt almost immediately. This would lead to a rapid decline in oxygen production and the beginning of a catastrophic chain reaction, affecting all life forms dependent on plants for food and oxygen. Within a few days, the global temperature would start to drop significantly as the heat from the sun, our natural space heater, disappears. Now let's talk about gravity. The sun's gravitational pull is what keeps Earth and the other planets in their orbits. With the sun gone, Earth would no longer be held in its orbit. Instead, it would continue moving in a straight line into space at about 67,000 miles per hour, the speed at which it orbits the sun. This would create an unimaginable shift in our solar system's dynamics. As weeks turn into months, the average surface temperature would plummet below freezing across the globe. Oceans would begin to freeze from the top down, drastically altering the climate and potentially triggering a global ice age. The lack of sunlight would also disrupt the weather patterns, eventually leading to a silent, frozen world devoid of the usual climatic sounds. Humanity would face extreme challenges. With the collapse of ecological systems, food sources would become scarce. Artificial light would become our only source of illumination, and sustaining life would depend heavily on dwindling energy reserves. This scenario, while scientifically unlikely, helps underline the critical role our sun plays in the solar system. If the sun exploded, the immediate effects on Earth would be catastrophic. Within just 8 minutes, the time it takes sunlight to travel from the sun to our planet, the world as we know it would plunge into darkness. This isn't just the night falling, it's the permanent cessation of daylight, casting Earth into a black void. As sunlight vanishes, so too would the warmth it provides. Temperatures would begin to plummet rapidly, dropping by several degrees each hour. Within a week, the average global temperature could fall to below freezing, transforming environments and making the survival of many species untenable. But the absence of light and heat is just the beginning. The Earth's atmosphere, intricately balanced by the solar energy it receives, would start to change. This could lead to the breakdown of atmospheric stability with the potential collapse of the ozone layer. Increased exposure to cosmic and solar radiation, without the protective shield of the ozone, could prove fatal to all life forms. The ecosystem would face immediate threats. Photosynthesis would halt, starving the plant life that forms the base of our food chain and leading to a rapid die-off in the animal kingdom. Furthermore, the effects on technology and communication systems would be profound. Satellites, crucial for communication, weather forecasting and navigation, would likely fail due to the intense electromagnetic pulse and increased radiation. Even as we grapple with these immediate disasters, Earth might also encounter space debris from the exploded sun. Chunks of solar material hurtling through space, which could impact our planet. The effects would be immediate and devastating, highlighting our planet's delicate dependence on the sun. Beyond the immediate chaos, the long-term consequences of the sun's explosion would reshape the future of Earth. With the sun's gravitational pull gone, Earth, along with other planets, would likely be flung out of their orbits. Cast adrift in the vastness of space, Earth would embark on a lonely, aimless journey across the cosmos. As Earth loses its central heat source, the temperatures would plummet rapidly. The once balmy and hospitable planet would transform into a frozen wasteland. Within weeks, the average global temperature would drop well below freezing, eventually stabilizing at about -250 degrees Fahrenheit. Oceans, rivers, and lakes would freeze from the top down, encapsulating marine life in icy tombs. The absence of sunlight would mean the end of photosynthesis, the primary process by which plants produce food and oxygen. This would set off a catastrophic chain reaction across the food web. Initially, plants would perish, followed shortly by herbivores, and eventually, the carnivores that depend on them. The biosphere, as we know it, would collapse, leading to the mass extinction of nearly all life forms. The broader impacts on the solar system would be equally dramatic. Without the sun's gravitational glue, the solar system's structure would destabilize. Planets and asteroids would drift into new paths, potentially colliding or being captured by other stars. The once orderly neighborhood of planets revolving around the sun would turn into a chaotic free-for-all in the dark expanse of space. In the long run, the absence of the sun would not only end life on Earth, but also disrupt the entire solar system. While today's exploration of the sun exploding is purely hypothetical, it serves a deeper purpose. We've journeyed through the stages of a star's life, understanding that our sun, a stable star, is far from the explosive end of supernovae seen in more massive stars. We've unpacked the layers of what would be a highly unlikely scenario, the sun exploding. And we've imagined the immediate and long-term cataclysmic effects on Earth, a narrative that underscores just how pivotal the sun is to our existence. Reflecting on these points, it becomes clear just how integral a grasp of celestial mechanics is, not just for astronomers, but for anyone curious about the fabric of our universe. It's a reminder of how the cosmic ballet goes on, with or without us, and how our understanding of such phenomena can deepen our appreciation of both the universe's vastness and its impact on our tiny blue planet. So, while the sun is secure in its current state, this thought experiment reminds us of our cosmic fragility and the marvels of the universe.